Okay, so welcome back. In the first part of this lesson, we talked about interpolation and how interpolation was finding the data that you wanted within the data that was already given. Well, in extrapolation, it's just not the case. It's using the graph to predict values that don't lie on the graph. It's beyond the data that's already given. So there's two different strategies we can use to extrapolate. We can extend the graph. That's no problem, but you got to make sure you know that you have a straight line, and you need a ruler for that. Sometimes you can't extend the graph, so you have to create a table of values, then determine the equation, and then use the equation to calculate the value. Now the second one, and if you watched part one, is way more accurate than the first. It's even more accurate than interpolation. So creating the table of values, determining the equation of the line, which we have done in Unit 4, Lesson 1, and Lesson 2, and Lesson 3, and then finding the value from the equation is the most accurate strategy of the three. So let's try and do this example. So suppose the same car maintains the same average speed. Predict the time it takes to travel a given distance. So here we have a graph of a car journey. We have distance and time. And I think this was the same graph that we did, or that we used in the first example yesterday, or in the previous lesson. So if I wanted to extend our line, let me see if I can, oh, there we go. So strategy one is extending the line. So you could actually take your ruler and extend the line. Now the only thing is that you run out of grid paper. So in order for you to do this, you would actually have to take other grid paper, draw the exact same line on bigger grid paper, and then extend your line, then interpolate. I think that is rather a tedious and not a most efficient method. So what I'm going to do is I'm going to find the equation of the line from the table of values. So let me just, can I move that? No, I didn't think so. Let me just move this up and so I have some more room. Okay. So let's create a table of values chart given. So time, distance. So when time is 0, they gave us really some nice points here. So time is 0, distance is 0. When time is 1, it looks like about 80 to me. Let's go back and check. Okay, so this is 50. That's a little bit more than half. A little bit more than half. I'm going to say it's 80. Let's see if the other one fits. So this one's a little bit more than 150. Yeah, that makes sense. Can you see the pattern? And then this one's just a little bit less than 250. So yeah, I can see. Remember, a linear relation, a linear relation means that there has to be a constant rate of change. So this pattern here is add 1. This one has to be add 80. Okay, you can't go up by 80 and then up by 70 and then up by 90. It has to be a constant rate of change. So I'm pretty confident with that table. Remember, if your independent variables go up by 1 and your dependent variables go up by 80, this is your numerical coefficient. So D is equal to 80t. That's what you have to multiply that time by. Then we check, do I have to add anything? Well, 0 times 80 is 0. Good. 1 times 80 is 80. 2 times 80 is 160. Okay, we're good. So that's our equation. So now, once I have the equation, I can find out any piece of data that I want. So what happens if I want, because I'm going to take this, and I'm going to go D is equal to 80, T. So what happens if I want T is equal to 10? What happens if I traveled for 10 hours? how far, if I don't stop and if I go a constant rate of change, all you have to do is times it by 80. And again, there's context, so don't forget your units. Numbers mean nothing when you have a context to the question. Okay, so what happens if you ask, how long will it take to travel, I don't know, 420 kilometers? Okay, so again, start with your equation because you know that's the equation of that graph. And you substitute the 420 in for your distance. And this one, you now know you have an equation, so you have to use those opposite operations. Whatever I do to one side, I have to do to the other. So what is that? Holy cow. Am I losing it today? 5 point. I know it's 5 point. No, it's just a Saturday morning. So 420 divided by 80, whoops, is 5.25. I should have known that. Hours. Okay? So once you have that equation, you can find any piece of data that you want, and it's way more accurate. We can go back and just chat. No, we can't. No, we can't. So I'm just going to not talk there. Okay, so here's another example. Example 1. The following data represents cost in money of a taxi ride as a function of distance traveled in kilometers. Well, we have some discrete data there because it's not connected. So what they're saying here is 0 kilometers is $2. Okay? So even before I even travel, I just step into that taxi, I have to pay $2. Okay? Then I travel 1 kilometer, it would be $3. So there's nothing in between. So you're getting charged $1 for each kilometer. Okay? So I can actually go put my data in there to follow the pattern. I won't connect the line because it's discrete data. Okay, so I can actually go put my dots in. Even though they're not there, it still follows the same pattern. So it says, I'm just going to stop. Let me erase that one. Okay, so it says, what's the approximate value of the C coordinate when D is equal to 2? Okay, so D is equal to 2 right here. Again, I go up. That's within the data that is given to us. So actually this is interpolation because it's within the data that's given to us. And it will cost us $2, $3, $4. Okay, so 2 kilometers, $4. So what's the approximate value of D, of the D coordinate when C is equal to 10? Okay, so now I'm going beyond the scope. So I go beyond the scope of the data that's given. So 5, 6, 7. The data only goes to $7. Okay, but I want 10. So this is called extrapolation. Okay, so let's go up to 10. So 5, 6, 7, 8, 9, 10. So that's 10. So in this case, I can actually use a ruler, and I'm just going to draw my dotted line in. I can use, and the reason why I'm doing it as a dotted line, oh geez, I don't want that one. I don't want to draw, I want the actual line. Okay, the reason why, I thought that's what I pressed. Okay. I'm just going to use a dotted line because if I put a solid line in there, I just changed it to continuous data. Okay, so I'm going to use my ruler, and the most important part is I have to go through the middle of all these points. So notice I'm not in the middle. Okay, I'm in the middle there. A lot of people just try to connect the points. You need to really go through the middle of the points to get a very accurate. So now even though I extended the graph, it is still extrapolation. I can now use interpolation, or sorry, the method we use in interpolation in order to solve, like using K10, going over, and then down. And this is the point we're looking for. So that's 5, 6, 7. That was 8. Okay. So it would be 8. That's funny. Okay, let me just get back to my undotted 8 kilometers. Okay, so what's the approximate value of the C coordinate when D is equal to 12? So D is equal to 12. So that's 5, 6, 7, 8, 9, 10, 11, 12. So we're looking way over here. Wow. So we actually have to really extend our graph, don't we? Right to the very end. Because I can see, let me just extend it. There. We're really lucky we didn't have to extend it any further. Okay, so 12 goes all the way up, and there's the point we want right there. So again, we go all the way across, and we're looking for that distance up. That's the same height. So this is 10, 11, 12, 13, 14. So it costs us $14. Now, since I had to extend the graph, it's outside the data that was given, we extrapolated. I really should be typing this. I type a lot faster. Okay. What is the approximate value of the D coordinate when C is equal to 4? Okay. So C is equal to 4. This is 2, 3, 4. Oh, look at that. We're just going backwards from the one that we did in A. So it's $2. Oh, so, ooh, sorry. 2 kilometers. Don't want to make any mistakes here. So $4 was here. We go over to our imaginary line, because again, it can't be a solid because this is not continuous data. We're just going to use this imaginary line to give us the data that we want, or the information that we want. Okay, so now since it was within the data points that were given, because it's within this point, it's in the middle of this point and this point, those were the given points, we know we interpolated. Okay. So in Unit 4, Lesson 5, we talked about interpolation, which was using the graph to estimate value points on the graph. And we also talked about extrapolation, where we had to extend the graph or we had to create the equation of the line. So make sure you do on page 176, number 4 to 11, and then hand in your assessment focus to me.